Hi students, this is Ms. Johnson with 5-4, Solving Compound Inequalities. Our sabbat for today is we're going to solve compound inequalities using the word and or, and we're going to graph our solutions in sets. Alright, well first of all we need to figure out what compound inequalities are. Well, a compound inequality contains two inequalities, two of them put together. If it uses the word and, both inequalities have to be true, and if our inequality uses the word or, only one of them has to be true. For example, we would read this as -4 is less than x and less than 7. Alright, a couple other words that you will see is an intersection, and an intersection is where two compound inequality graphs overlap. So they are overlapping, which would mean they are using the word and. For example, x has to be greater than or equal to 3 and x has to be less than 7. We can write these together as one compound inequality where yes, x is greater than 3, so that means x needs to be further to the right, and the variable always goes in the middle of the compound inequalities. So we're going to put the 3 first because that's the smallest, and 3 has to be less than or equal to x and less than 7. So as we graph this, we've got our closed dot on 3, we've got our open dot on 7, and it has to be in between. That x is in between, so our solution is in between those two. That's what we call an intersection. A union is when we use the word or, and two inequalities are graphed on the same number line, but it's one or the other. So if we have x is greater than 2, or x has to be less than or equal to 1, we graph both of them. So greater than 2, we'd put an open circle on 2, and greater than goes to the right. And we have less than -1, less than or equal to, so we need a closed circle on -1 and going to the left. One of these things has to be true. That's a union. Alright. Example number 1, we are going to solve -2 is less than or equal to x minus 3 minus 4. This is kind of a complex one to begin with, which is kind of fun. And what we can do is we can break this into two parts. We can take a look and we can solve this part of -2 is less than or equal to x minus 3. And that's just like the other day, so we're going to go ahead and solve those. The other thing we can do, let me change my color again, is we can take the right hand side and we can have x minus 3 being less than 4. And we can take these as two separate inequalities, but they're all together, so we're using the word and, so both of them have to be true. So let's solve the first one. -2 has to be less than or equal to x minus 3. Well, to get the x by itself, we got to get rid of the minus 3. So opposite thing is we're going to add 3 to both sides. Add 3 to both sides, and we get 1 is less than or equal to x. With our other equation that we have come up with, I should say inequality, we have x minus 3 has to be less than 4. To get x by itself, again, we're going to add 3 to both sides. Add 3 to both sides, and we get x is less than 7. So for our solution, we have 1 is less than or equal to x, and x has to be less than 7. To graph these on our number line, what we're going to do is we're going to combine these first of all into a compound inequality. The variable has to go in the middle, the x. And the way this is written is perfect because the 1 is the smallest thing, and we can keep our less than or equal to. 7 is the greatest thing, so we can keep that on the end and put in our inequalities. Then what we're going to do is we can graph them separately though. If x has to be 1 is less than or equal to x, that means we're going to go to 1, and it has to be less than or equal to, so that's going to be my closed in dot, and I'm going to go right here at 1. And the x has to be more than that, so I'm going to go to the right. Alright, if I take my other inequality, x has to be less than 7, so that's my open dot. Less than 7. 5, 6, 7 is going to put me about right here. And if I move up here, that means we need to have everything less than that. So that's going to be everything that's in between 1 and 7. It can include 1, but it cannot include 7. So any of these can be solutions. Alright, example 2. We need to solve for the variable m, and we're going to graph when we have negative 2m plus 7 is greater than or equal to 13, or 5m plus 12 is greater than 37. So we're going to, again, solve these separately, and one or the two of them needs to be true. So negative 2m plus 7 is greater than or equal to 13. Let's see, we got to get rid of the 7 first, so we'll subtract 7 from both sides, and we get negative 2m is greater than or equal to 6. And then we're going to divide both sides by negative 2, divide by negative 2, and we are left with m is greater than or equal to negative 3. But I just divided by a negative, so what do I need to do? Yes, I need to flip my sign. Instead of being greater than or equal to, it is now less than or equal to. Good catch. Alright, then we need to solve our OR inequality. We have 5m plus 12 is greater than 37, so we need to subtract 12 from both sides, and we get 5m is greater than 25. Divide by 5, divide by 5 on both sides. So we have we have m is greater than 5. So either m has to be less than or equal to negative 3, or it has to be greater than 5. So we're going to go ahead and graph both of these on the same set of number line. So m greater than or equal to negative 3, we're going to use our closed in, filled in circle, and we're going to go to negative 3, 1, 2, 3, and I'm going to put my filled in dot, and it needs to go less than, so I can take this arrow and going to the left. It's going to be less than. Or m has to be greater than 5. So I'm going to go to 5, I'm going to put my open circle, because it can't include 5, just greater than, and m's going to be greater than, so it's going to go to the right. So any solution over here will work, any solution over here will work. Okay, so m has to be less than or equal to negative 3 or greater than 5. Alright, thanks for tuning in. That is 5-4 compound inequalities.